Hi folks, Mr. Long here. We're going to go through the process for determining an inverse function given an original function. Okay, the inverse function given an original function. What we're going to do is start with a parabola that's in a table of values, and from this single representation, a function with a table of values, we're going to get the inverse for the table, the equation, and the graph. Okay, all three. The table, the equation, and the graph. So to begin with, let's go ahead and get the inverse in a table form. So what we remember from class, hopefully, is that when we're getting the inverse in a table of values, we're just interchanging x and y. The y-intercept would become the x-intercept. The x-intercept becomes the y-intercept. We interchange the domain and the range. Okay, so for this one, the first point of -1 and 0 becomes 0 and -1. 2, 9 becomes 9, 2. 5, 0 becomes 0, 5. Okay, so our x-intercepts turned into y-intercepts. Next, we want to make a graph. Okay, the next thing we want to do is to make a graph. Now, what we said, I think, is in class, hopefully you remember that I just look, when I'm doing this with inverse functions, I want to have as square a graph as possible because symmetry is based on the line y equals x, which is over 1 up 1 over 1 up 1. So we'd be able to see the patterns of symmetry a little bit clearer. So what we do is we look for the absolute lowest value, -1, and I look for the highest value I see in the table for anything of x and y, and it's 9. So that means my axes, x and y, are both going to have to go from -1 to 9. So I'm going to draw now an axis on this graph. So there, and then it's going to have to be very similar distance there. Now, if I were a little smarter, I probably would have used the grid points, but nonetheless, that will work, I hope. So we want to go from -1 to 9. Then this right here would be -1. Whoops, -1 there, all the way up to 9. Okay, so now what I need to do is to plot the points. So I'm going to plot the points for the original function first, the parabola, -1, 0. Then it's going to be 5, 0 for the other x-intercept, which is going to be right about there. And then the other point is 2 and 9, so right in the middle up here. Okay, so now we can see that it's actually looks like a nice parabola. So now while we're at it, we might as well make a graph of the inverse, okay, of the inverse. So again, our y-intercepts become our x-intercepts become our y-intercepts. So the first point is 0, -1. That's right there. Then it's 9, 2, all the way out to 9 and up to where 2 would be, which might be right about there. Oh, by the way, I should be marking that 2 there. So 2 would be right around there. And then the other point is 0 and 5. 0 and 5. So we would be up right about, 5 would be right about there, I'm guessing. Okay, so, or maybe there. So what we want to do now is to graph our parabola, or square root function. So I'm going to graph that part, it comes down, and then goes like so. Okay, goes like so. And because of it's only an approximate sketch, it's not going to look perfect. One thing I am going to do here is to recognize that this is not a function because it fails the vertical line test. So I'm going to show it in 2 branches. Okay, so there's our 2 branches for our square root function. All right, so first things first though, now we need to go ahead, now we've got a graph of the original function and the inverse function, and we can see, by the way, that we have a pretty good idea here. The line y equals x would go through like this. Okay, would go through like that. All right, and now what we want to do is get the equation of that parabola. Okay, so we need to work with equations. So how do you get the equation of a parabola? Well, one of the things you need to do is to get the slope, the a value. And to do that, we need delta y over delta x squared. So remember that delta y over delta x is for a line. It only makes sense then that delta y over delta x squared gives you the a value for a parabola. And you would want to look back. I did a video before this on how to get the a value in parabolas. But what we're going to do here is just quickly sketch out our delta y and delta x. Okay, you're always going to the right of the vertex. And if we look at this, this distance here, so this is delta x, and it looks like delta x goes from 2 to 5, so delta x equals 3. And here's our delta y. Our delta y goes from a y value of 9 all the way down to a y value of 0. Well, that's going to be negative 9. Okay, so there's delta y and delta x. Now we put it into our formula. Negative 9 divided by 3 squared. And what's that worth? Negative 9 divided by 3 squared. 3 squared is 9. Negative 9 divided by 9 is negative 1. There's the a value, or the slope, of our parabola. What I do now is put it into the general form, okay, for the equation, which is ax minus p quantity squared. When I say quantity squared, I mean the things are in a bracket, plus q. Okay, plus q. So I've already put this in, so it's negative 1 for a, and the vertex we know is at 2 comma 9, so that's going to become minus 2 plus 9. All right, now we're going to go through the process of, so that is the y value of the original function. Now what we're going to do is go through a process and get the inverse of that. So what's the first thing? What's our process for getting inverses? It's right here. First thing I do is interchange x and y. So I remember that we do that in the table. We switch x and y. And I name y inverse because I'm switching x and y. Y inverse is named as y to the minus 1. I could put f at x and f of x to the minus 1. It's just a little bit quicker when I'm doing this algebraically to write y to the minus 1. Okay, then what I do is I switch sides. I only do that because I find it easier to isolate things from left to right. And then finally, what I'm going to do is do inverse operations because that's also part of inverse function. Okay, so I've already done that. So I've switched x and y. I put where I had x here, I put y inverse here. Where I had y here, I put x here. Okay, and I switch sides just for ease of algebra. Next thing I want to do is to isolate for this y inverse. I have to do that by looking at bedmass and inverse. Okay, bedmass and inverse. So if I look, what's the first thing that's going to happen to, in this case, y inverse is minus 2. What would the next thing be? Squaring. What would the next thing be? Multiplying by negative 1, and finally adding 9. So let's record all of those things. Minus 2, square, multiply by negative 1, plus 9. Now let's do the inverse. Minus 9, divide by negative 1, square root, plus and minus, plus 2. Okay, so now we can go through this. So x, so the first thing we're going to do is, we're going to have x, and the first thing we're going to do is minus 9. Okay, the next thing we're going to do is to divide by negative 1. Dividing by negative 1 is the same thing as multiplying by negative 1. It just changes the sign. Like 10 divided by negative 1 is negative 10. X divided by negative 1 is negative x. It just changes the sign. So what I can do is just make that negative x plus 9. Okay, negative x plus 9. And now what I do is plus and minus square root. Okay. Finally, I do plus 2. I have to remember the plus and minus of the square root. Now, there's one thing on here that I noticed that I should represent it a different way, and I should always, if there's a negative out front of that x, I should factor out the negatives. So y to the negative 1 equals plus and minus square root, negative bracket, x minus 9 plus 2. And that, folks, is the algebraic inverse function. What would a rough sketch of that look like? Okay, what would a rough sketch of that look like? Well, let's see. I'm going to draw my straight line. My straight line would be the negative of x minus 9. So that means we're going to be here, and it's going to go like this. So where are those y values positive? Where can I determine a square root function? Like that. Okay. What's the other thing I need to know? I need to know that it's going to shift up plus 2. So it's going to shift it up like that, plus 2. And that would be the positive version. But there's also a negative version below that goes like that. Now, does that look like what we found? So that's at 9 and 2. So let's go back up to our graph and see if we're right. Verify. Well, would you look at that? It's at 9, comma 2. Okay, there we go. And you know what? That's enough verification there. I think you don't need to substitute in values, but we can see that. Remember, though, that that's a non-function. So we have two functions here that make up the inverse. The positive version, which is on the top, and the bottom version, which is negative. Okay? So again, what you want to do there is emphasize that you can get the inverse algebraically. You can get the inverse on a graph by drawing a graph. You can get the inverse of a table. Okay, and that's what you need to be able to do, the inverse function. And then to remember that there are two functions, the positive and the negative. Okay, taken together, they're not a function. Okay, good luck as you work through that handout.